Here there are two cables, coaxial cables. First cable is a solid cable of radius r, and there is current uniformly distributed throughout its volume. Okay, uniform current throughout its volume, and there is another cable of radius 4a. That means you have to find the this inductance per unit length of the cable. Now, obviously, through this outer thinner cable, current may go in the other direction, the reverse direction. However, whatever be the current in the outer cable, it will not affect the flux in the region between the cables. We need to find the flux in the region between the cables. Now you know about the magnetic field at a distance r. That means if r is greater than a, then magnetic field is mu 0 I by 2 pi r. This is B. And if it is inner, that means if this r is less than, if r is less than a, then B is equal to, then it by this Ampere circuit or law, how can you find out B into 2 pi r? That means you consider an amperial circuit like this. So B into 2 pi r is equal to mu naught into I by pi a square into pi r square. So therefore B is equal to mu 0 r mu 0 I r by 2 pi a square. That is the formula then. So it is mu 0 I by 2 pi a square times r. Now you have to find the flux. So for finding the flux, you have to do this integration in this whole region. Say consider a length dr, and say if you consider the length dr, and suppose for the length is equal to 1, that means the length parallel to the axis, this L is equal to 1. So this distance is equal to dr, and there this magnetic field is downward for this point obviously, and if you consider the point here, it is upward. Okay, so you have to find the flux, magnetic flux in this region. That means from 0 to 4a. Now let us do that. So that flux is equal to, let us choose this internal region. So there it is, mu 0 I r by 2 pi a square times dr, because length is 1. So this is from 0 to a, plus it is mu 0 I by 2 pi r times dr, that is from a to 4a. Okay, so this becomes mu 0 I by 4 pi a square r dr r square by 2. Therefore you have a square here, plus mu 0 I by 2 pi into log of 4. So that means it is this a square will cancel. So mu 0 by pi into, let there be I also, phi is equal to I times mu 0 by pi 1/4 plus half log 4. That means it is mu 0 I by pi into 0.25 plus log 2. Log 2 means 0.693. So 0.693 plus 0.25 is 0.943. So 0.943. So phi by I, that is inductance, is equal to mu 0 by pi into 0.95 approximate. So the value of n is very close to 1.